In outdoor environments, illumination changes and high dynamic range scenes are two omnipresent problems for vision-based algorithms. They generate saturated pixels, as shown for a boreal forest example. Therefore, automatic exposition algorithms are developed to be more robust and be adapted to vision-based robotics. Unfortunately, given the online nature of exposure control, comparing automatic exposition method is very challenging. We divide the existing comparison methodologies for automatic exposure algorithms in three categories. Using multiple cameras allows exact comparison, but increases rapidly in complexity with the number of methods to compare. Repeating the same trajectory has to be deployed in a controlled environment, but provides a precise ground truth. Multi-exposure of the same static scene has the benefit to be usable offline, just like our method, but it does not allow to work on trajectories since the camera is static. Our main contributions are an offline emulation framework that provides the ability to emulate images at any desired exposure time based on images acquired using the bracketing technique. Our second is Boreal HDR, a multimodal dataset that works with our emulator. And finally, we produce an offline benchmarking of 7 automatic exposure algorithms. As input to our system, we use one exposure time cycle from our bracketing. Then, we find the two images from our input which bound the target exposure time and select the less saturated. Finally, knowing our source image and its corresponding exposure time, we can emulate the desired image following this equation. Here, f is a camera response function. With our emulation protocol, we are able to produce images at any exposure time for the same scene, as shown here, where we randomly emulated images from 0.5 to 40 milliseconds. Since our emulation framework is based on bracketing, we collected stereo images using our acquisition platform. In the bottom right, we can see the bracketing images collected at 22 fps. We also gather LiDAR, IMU, and GPS data. For the bracketing, we collected 6 different exposure times, which are displayed here separately. In addition to the raw data, we also provide 3D maps created using the iterative closest point algorithm and the LiDAR data for each sequence. Our dataset Boreal HDR contains 50 trajectories, which sum for 8.4 km and a total of 4 hours of data. We divided the dataset in 4 environment types: forest roads, snowmobile path, open spaces, and narrow trails. We show here how our approach generates images with the requested exposure times coming from 4 different automatic exposure algorithms. Note that the poses are the same for all 4 automatic exposure algorithms, allowing for fair comparison. The benchmarking was performed using 4 experiments for each of all the 7 compare methods. We display here the performance on a stereo visual odometry pipeline compared to a ground truth, showing that the methods having the minimal error are shim with 3%, classical auto exposure with 2.9%, and Zeng with 2.6%.